What will you do if you are asked to find the number of ordered pairs of integers x and y from this expression? This is an AIME 2000 maths problem. We are asked to find the value of x, the pairs of ordered integers x squared minus y squared equal to 2000 squared. What will you do? To solve this expression, we need to apply an algebraic formula. And once we apply that algebraic formula, we can be able to find the greatest value of x plus y and the smallest value of x minus y, and then we can take off from there. I'll see how we are going to break this into smaller expressions. From this mass expression, you agree with me that a square minus b square, which is an algebraic expression, can be equal to a plus b multiplied by a minus b. This is a diff of 2 squared. Now if I apply it to that expression, I'll have my x plus y multiplied by x minus y to be equal to 2000 squared, which is going to give me 4 million. Now to get the greatest value of x plus y and x minus y, I can see that this can give me 4 million multiplied by 1, right? And so I'll have my x plus y and then x minus y to be equal to this. While this gives me the greatest value of x plus y, this is going to give me the smallest value of x plus y. So I can equate that expression to give me my x plus y to be equal to 4 million. And my x minus y can be equal to 1. Having gotten this as the greatest value of x plus y to be equal to 4 million, while the smallest value of x plus y can be equal to 1, I can find the range of value for these two expressions. From here, I can see that the range of value of my x plus y can range from 4 million, can also have 2 million. From here, I can have 1 million. From here, this can stretch out to 4, 3, 2, and then I'll have 1, right? And my x minus 1 can be equal to, I can have my 1, I can have my 2, 3, and it increases that way until I have my what? My 1 million, which is 10 to the power of 6. I can have my 2 million, and it will end up with what? With 4 million. Great. Now, having considered that range of value, I can decide to subtract these two expressions. If I subtract these two expressions, if I add these two expressions, this will cancel out this, and then I'll have my 2x to be equal to this expression. While if I subtract these two expressions, I'm going to have x cancelling out x, then I'll have my 2y to give me what? The expression. While this is addition, this is going to be subtraction. So that tells me that I can be able to have my factors from these two expressions, my pair of factors from these two expressions, ordered in the way they can. Now let me consider 4 million. But how many factors can I get from 4 million? Now let's consider 4 million. If I consider 4 million, how many factors can I get from 4 million? If I have my 4 million, my 4 million can be 4 multiplied by 10 to the power of 6, right? So I can have my 2 to the power of 2 multiplying 2 multiply 5 and all to the power of 6. While this is equal to 2 to the power of 2, this can multiply 2 to the power of 6 multiplying 5 to the power of 6. According to the law of indices, I'll have to expand that, and this is going to give me 2 to the power of 8 multiplying 5 to the power of 6. Now let me consider expanding this. If I blend this with the expression I have here, let me blend this to give me the expression 2 to the power of A multiplied by 2 to the power of B, with A being equal to this expression and B equal to this. That means the ranges of values of A can be 1, 2, 3, and 4 up towards 7, and I will have 7 numbers, right? And the ranges of the value of B can be equal to 0, 1, 2, and it ranges up to 6, and I can have 7 numbers. So what do I have? 7 multiplied by 7 can give me the factors of 4 million. That will give me 49, and 49 will be the number of factors I can get from 4 millions. That means, what does this mean? It means that if I find the pairs of this expression, which ranges from x plus 4 plus y, 4 million to 1, if I take these two expressions, x minus 1, which ranges from 1 million to 1 to 4 million, I can have this as a what? As a pair. I can have this as a pair, and all these as a pair will give me 49 factors. This will give me 2 factors. This will give me 2 factors, 2 pairs of x plus y. This will give me 2 pairs of x comma y. This will give me two pairs of x comma y, while this will also give me 2 pairs of x comma y, and that continue that way. That is what we mean by 49 different factors. Now if I do all that, I'm going to have 49 different factors, two factors from each of those expressions, which is going to give me 49 and 49. So what does that expression mean? So here, let me take a good example of 2 million and 2 million and 2. If x plus y is equal to 2 million as a factor, and x minus y becomes equal to 2, what factors can I get from this expression? From this expression now, we can get the pairs of factors for these two expressions. From these two expressions, if I add both sides, I'm going to have my 2x to be equal to 2 million and 2, right? And if I divide here by 2 and divide here by 2, I'm going to have the value of my x to be equal to, my x will be equal to 1,000,001, right? So if I simplify the value of x into any of that expression, I'll have my pair of x comma y to now be equal to, this will give me 1,000,001, and I'll have the other one, the value of this, to give me 99999, and this will be the value of x comma what? Y, which is a pair that will come out from what? From that. Now if I subtract these two expressions, if I subtract those two expressions, I can have my what? My 2y to still give me that expression, and then my x comma y can now be equal to 1,000,001, and then I'll have my negative 999,999, right? Negative 999, and then I'll have my what? 999 as the second expression. This is x and this is what? Y, from the negative part of that what? That expression. Now we see that I can have 2 ordered pairs of x comma y from this expression. Now if I do that for the value of, for this range of value 4 million to 1, 1 to 4 million, I can be able to have two different pairs. And what are the pairs? I can be able to have 49 ordered paired from one expression from the addition, and I can be able to have 49 ordered pairs from the subtraction of each of those ranges of value from the addition and subtraction. And then when you add these two pairs, 49 plus 49 is going to give me 98 ordered pairs. And that tells me that 98 ordered pairs is the solution, is the number of paired solution I can have. 98 is the order of x, y pairs I can have from that expression given to me up there. So you see, it's very easy. All you need to do is to find the range of this value and find the pairs that can come out from each of these range. And 4 million can give us 49 factors, and that tells us that we can have 49 pairs from the positive aspect and 49 pairs from the negative aspect, and that expression will give us 98 pairs in totality, ordered pairs in totality. So you see, very easy. If you want to more solutions like this from our maths content, don't forget to give this video a thumbs up, share it with friends and colleagues, and remember to subscribe to my channel for more simplified maths content. Thanks so much for watching, and bye bye.